Greetings! My name is Dr. Sara Strey, and I'm here recording this video to introduce you to the climate computing stream here within the FIRE program at the University of Maryland. Just a bit about me. I got my PhD in atmospheric sciences, and I love to study how changes in different aspects of the Arctic climate system interact with and impact our weather and climate patterns here in the mid-latitudes, especially the continental United States. Speaking of weather and climate patterns here in the U.S., we see evidence of climate change's impacts on a daily basis, from changes in track patterns bringing flood-inducing hurricanes further inland, to hotter summer after hotter summer being the next warmest year on record, and impacts in the Arctic on the polar ice. In fact, in 2024, the Arctic had its second warmest year on record, and that record spans over 125 years, might I add. And autumn of last year set the #1 hottest autumn for the Arctic. Meanwhile, the sea ice cover has been reduced by nearly 50% when compared to the 1979 to 2000 average. Each of these records just keeps getting set and broken, and it's so easy to feel powerless in the face of how big it all is. But what if I told you that you could contribute to the collective understanding of climate change, bringing only a curious mind and a willingness to learn with your cohort into the climate computing stream with you? Thanks to education grants through the National Centers for Atmospheric Research through the National Science Foundation, we have the amazing opportunity to study and practice weather and climate modeling on Derecho, the same high-performance computing cluster used by premier meteorologists and climatologists all over the world. No need to be intimidated by this supercomputer's 318,000 plus core computing cluster. We'll learn how to navigate and use the system, and it's so easy with Linux commands and the programming tools you'll learn here in FIRE Climate Computing. And what do we do with all that supercomputing power we're given to use? Well, some of our current projects in the last year have included a study of the cold air outbreak climatology, including energy fluxes, the relationship between Arctic Ocean sea ice cover and things like atmospheric rivers, which can cause really damaging rain on snow events in the Arctic, Northern Hemisphere seasonal weather and climate patterns, and the nature of clouds and precipitation in the Arctic and beyond. This is just the beginning of what we can do, and even without prior knowledge, you can come into climate computing, continue to contribute to the understanding of climate and climate change, and have a great experience that can be applied to almost any career path, especially those in tech. And with that, I appreciate your attention, and I really hope to see you in FIRE 298 under my section of climate computing this coming spring 2026.